Good morning, good afternoon, and good evening to all of our attendees joining us today for this latest Data Science Central webinar. This is Bill Vorhies, your host. I'm the Editorial Director with Data Science Central and also Chief Data Scientist for Data Magnum. I'd like to start off our event today by thanking RapidMiner for sponsoring today's event. RapidMiner is a longtime supporter of the Data Science Central community, and we're honored to have them sponsoring our event today. I'd also like to take this opportunity to mention and show our appreciation for some of our other recent sponsors, including Tableau, MapR, Microsoft, Hortonworks, Oracle, and IBM, to name just a few. Past webinars are available on demand at datasciencecentral.com. If you haven't had the opportunity to view them, I encourage you to take a look. They provide very useful insight into a wide variety of topics of interest to our data science community. Today's webinar is entitled Data Scientist Workbench Accelerates Predictive Analytics. And before we begin, I'd like to briefly review the format of today's webinar. Today's event will be an hour long. We have one panelist that I'll introduce in just a minute. There'll be a 10 to 15 minute Q&A following the presentation. And this event is being recorded and will be available on datasciencecentral.com later this afternoon following this morning's live presentation. I'd also like to encourage our attendees to provide questions throughout the presentation. We'll be reviewing and presenting them on your behalf during the Q&A portion of today's event. So I'm very pleased to introduce today's speaker, Martin Schmitz with RapidMiner. Martin is a sales engineer at RapidMiner. As a product evangelist and technical expert, he's responsible for promoting RapidMiner's predictive analytic platform and ensuring data science customers are informed and enabled. Martin studied physics at TU Dortmund University. Being part of several interdisciplinary research centers, he divided his research activities into computer science, mathematics, and statistics. In addition, his research efforts, Martin also taught data science and the use of RapidMiner for predictive analytics. Thanks for being with us today, Martin. We're looking forward to your presentation. New technologies, big data, and increasingly complex multidimensional data relationships create a challenging environment for modern data scientists. In today's DSC webinar, we'll discuss a modern predictive analytics platform to help manage and accelerate all phases of your predictive analytic process lifecycle, from source to result. So in today's data science webinar, you'll learn how this agile digital workbench allows you to streamline tedious and productive tasks, access and prepare data for predictive analytics, rapidly prototype and validate your models, leverage your existing R and Python, extract maximum value from Hadoop, share results with the rest of your business, and quickly enable embedded analytic results into the business process. So Martin, with that, I'm going to turn it over to you. You can begin as soon as you're ready to go.
Hello everyone, and thank you, Bill, for introducing me. As Bill already mentioned, I am data scientist at RapidMiner, and we continuously run into one problem. Our boss comes to us, so during my PhD thesis, my professor came to me and said, "Hey Martin, I got this cool idea. It takes you 2 days to implement this, and it will be a cool chapter of your thesis." Guess what happened? It didn't take 2 days, but rather half a year, and was not just one chapter of my thesis. So non-data scientists, in this case, okay, my professor was quite skilled in stats, but non-data scientists come to us and say, "I want answers now." And we would like to talk a bit about this problem and how modern data science workbench can help us to accelerate all parts of predictive analytics through the whole life cycle. So what are we talking about today? What's the agenda? So we will talk about the challenges we face as data scientists. After which I would like to introduce the concept of a data science workbench and show you what a workbench needs, which tools need to be on our workbench to accelerate workflows and make essentially our life as data scientists easier. After this part of which is backed by slides, I will move over into RapidMiner and show you a demo about how to do this practically, and I'll use a fraud data set to show what to do. In the end, of course, you can ask questions and we will move over to a question and answer session. So, what's RapidMiner? RapidMiner is a modern predictive analytics platform which was built by data scientists. So, as Bill mentioned before, I'm coming from TU Dortmund University, and this is the university where RapidMiner was founded. We started in university and grew to a big enterprise platform. And the people who started to build RapidMiner, like Ingo Misra, are actually data scientists. And you will see at many points in our software that we are data scientists, and there are a lot of concepts which will help you. Even though we started at university, we are positioned as the leaders quadrant of Gartner, and we have more than 1,400 customers and a very huge open source community of more than 250,000 users. So, what are the challenges we as data scientists face? Well, data is diverse and dirty. If my boss comes to me and says, hey, I got this cool data lake, there's some data, and could you analyze it? I say, sure. And how to join this, or how to interpret those values? Data is diverse and dirty, coming from very different sources, like there's social media, time series data, maybe even image data, different data warehouses, and guess what? Often Excel is treated like a database. On the other hand, our predictive modelings require clean and good formatted data to work. And in the end, a lot of people don't understand that how complex it is to do that stuff. It always sounds that easy, right? Nevertheless, technology is still changing. Like half a year ago, we hadn't had that cool Spark R, Spark Python, or PySpark was already there, but it's constantly changing. What was hip 5 years ago is old school nowadays. And last but not least, our day only has like 24 days, and we can't work for 48 hours a day. And this is something also other people, other data scientists, not just me telling you. So the most important problem or challenge data scientists face is too much time spending on cleaning data, or on the biggest challenge is also poor quality of data. And in the end, also insufficient time to do the analysis. So what can we do to make it better? We need a data science workbench. Data science workbench is one platform to rule them all, which gives you all the tool sets you need to wrangle down your data, to get to clean data and do the analysis. One platform with multiple options, multiple tool sets. Let's go through one cycle of CRISP-DM to realize where do we need or where do we spend time. And of course, there's the first step in CRISP-DM is prepping data. So we need to easily connect to any data source and clean and transform it. We need to prepare the data specifically for data analytics. For example, removing outliers, defining labels, or whatsoever. Because in the end, like a lot of our quality of our prediction depend on the quality. We need to model, and we need to model fast. I would like to rapid prototype fast, like which better decision tree against naive Bayes or random forest, or should I go for neural net? That should be done very, very fast to accelerate everything. Further, we need this platform which is able to validate and optimize all my processes, so all my methods. I would like to optimize my models in validation, which also includes the pre-processing. like normalization is part of the method, and what's part of the method should be validated. And last but not least, we would like to deploy our method. We have a very cool method. Now let's integrate this into something to make value out of our cool method. So what's part of the tool set after we identified all our challenges? Of course, access to all data types, structured, unstructured, big data, interactive visualizations. I'd like to get a very, very quick view. Do I have something in there? Is there a correlation? Let's do a scatter plot, a histogram, or a density chart, whatsoever. That should be very, very fast. I would like to have outlier detection, normalization, even maybe some dimensional reduction, like a filter method or something. Everything like that should be included in a workbench. I would like to have the complete picture of modeling. Predictive modeling, clustering, regression, classification, association mining, feature weighting, all that stuff should be included, and not only like the top 3 linear regression decision tree fun. Of course, we need stuff like cross-validation, bootstrap validation maybe, or splitting. There should be the pre-processing should be included in the validation, and of course all kinds of metrics to validate. And last but not least, I would like to score fast and use web services to integrate, maybe build a dashboard on top of my stuff to monitor everything. And guess what? This is what RapidMiner is giving you. So before we move over into the demonstration, I would like you to remind you what to look at. Like, we would like to streamline all the repetitive tasks you have. We'd like to prepare data pretty fast, and it shouldn't take that long. We'd like to rapidly prototype and validate our models. We would like to leverage from R and Python. So I'll focus on Python, but it's working with R exactly the same. We'd like to include also unstructured data, easy to collaborate, and all the good stuff. So this is what you might want to have a look at while I start the demo. So this here is RapidMiner Studio. RapidMiner Studio is kind of a workbench to run all your processes. A process is basically the script you want to execute. All RapidMiner processes are code-free if you want to. So there's no need for coding, but of course we allow you to code in R, Python, Octave, JavaScript, or even in native Java. RapidMiner Studio is open core and it's available on GitHub. So let's start and get some data in. I prepared something for you, which is a data set. I called it here old customers, which is an Excel file. How to get the Excel file in? Yeah, well, let's drag and drop it in, and that's it. In order now, so this here is a so-called operator. Operators are the building blocks of your processes. Usually an operator is something where a table goes in and a table goes out. And in between there happens something with the table. Obviously there are some tables where only stuff goes out, like in this case, read Excel gives you only something out. You can actually plug in a file object. There are sometimes operators where more than one table are going in and one is coming out, like join, you know, from SQL. But in principle, it's table in, table out, several tables in, several tables out. Here on that small half circle, we actually call them port, comes our data out. So what we can do is connect them here to the right, and now the data is streaming right through this line, and everything which is connected here to the right will be displayed once we run our process. To run our process, we simply click the play button. After running the play button, we read in our data set and directly jump to a table perspective of our data. We see that we have several columns here. We call our columns attributes and our rows examples. That's RapidMiner terminology. And we have a gender, which is 1 and 2. We have a state. We know if it's a cardholder, his balance, his number of transactions, its number of international transactions, a credit line, and we know something about the customer ID. We would like to predict churn, and luckily our experts already tagged whether it's false or true. In some cases, it's a true fraud. And we would like to tackle this later on as a supervised learning problem. This is only a good view on the data. What we also get is the statistics. What we get here is a good overview. We see that we have no missings in our data, that we have one polynomial, so some string like some class is not a real string, thing which is fraud risk, and everything else is an integer. We also see the minimum, the maximum, the average, and the deviation. So there's a very quick, good overview, and you might also see outliers here. If I click here on gender, then I get a small histogram here. And if I click on open chart, then I'll even get a bigger histogram of it. I jump here to the charts perspective. And if I open this one here, you see that you get the full charting options like scatter plots, series plots, even zones are included, density, pie chart. Whatever you want is basically included and easily accessible for you. Let's go back to the design perspective. So this data is coming in from my Excel file, but I like to store that. And I don't want to read all the time from hard disk. So I got something here which is called repository. A repository is simply a place where you can store data, but also results like models, performances, and processes itself. We have a client-server architecture, so I could store my stuff on my laptop or on a server. Actually, this server is running also on my laptop because RapidMiner server only needs a SQL database and Java. So we have here a folder structure. It's a bit structured like Linux. And I've got also a folder DSC, and I like to simply store that one in here. How do I do that? So you see here is a huge repository of operators where I can click through and find the operator I want to. I also can simply type in store, and guess what? The store operator stores data. So I'll first store the process itself here with right-click and store process here, or using the save button up here, and call it a one read-in. And now I can use here relative path, like you know it from Linux. In this case, I only store that as raw data. And if I run this, I get here my raw data, here on the lower left. Let's start another process in order to pre-process our data. So run a new process, and now I can simply drag and drop in this raw data into my process. I'll store this as O2 pre-processing. And now I can also say, take a relative path, which is a bit better than an absolute path if you want to execute it afterwards on server. As the next point, I would like to throw out a few examples. If I run this, we will see that if I go to statistics again, there's state is between 1 and 51. I'm not sure what state 51 is. Maybe it's DC. I'm not sure. I like to exclude the state with the number 51. How do I do that? I would like to filter examples. You see that we have here recommended operators, operators other people might use. As I said, we have a community of 250,000 users. You can opt in and send us anonymized versions of your processes. And we do data mining on data mining processes and have a recommender which recommends the next best step. In this case, one of this is actually filter out examples. And that's what we want to do. Now, here on the right, I see parameters. I can configure my filter. Let's add a filter and say, okay, I would like to have state smaller than 51. If I run this now, then I will see at statistics, my maximum state is 50. Everything went well done. Let's state results here. We have here something, the fraud risk is the target variable. And further, we have also a customer ID, which is an ID variable. Unlike in Python or R, we can actually define special roles. Every column, every attribute can have a role which gives either special meanings, like label or ID, or simply some meaning, so it's excluded by any other operator unless you explicitly say, please use it. That could be, for example, for a name. You don't want to throw out the name of the customer, but maybe just ignore it for the learning. So let's set the roles of customer ID to ID and a fraud risk to label. To do that, we go again to design. And there's an operator called setRole. Let's drag and drop that one in. It's also recommended by our recommendation algorithm. And say, okay, fraud risk should be label, and I can set additional rows and say, what was it? Customer ID should be ID. I can run this one again, and now there's also color coding. Everything which is green is somehow related to a model, and blue is in this case an ID. Okay, that's great. As the last step of pre-processing, I would like to generate a new column. To do that, we use generate attributes. Again, it's recommended. Could be good. And here I can say I'd like to create a new column, a new attribute in our terminology, and I name it Delta Transactions, which is total transaction minus international transactions. I can click on this small calculator here and get a very cool function parser, and it's simply supporting very, very different things, similar to Excel. We can see here text transformation, cut, concat, replace, lower, upper, suffix, math functions, square root, and whatsoever. So there's a huge variety of functions. I only want to have number of transactions minus number of international transactions. Only once is fine. That's it. We created a new column. If I run this one here, then I get here delta transactions as a new column. I store this one again, and now this is okay for my data prep. We don't have that much time, but I think you know how this works. I could add a join or select attributes to throw out columns. Everything is included what you want to have. So let's start a new process, and I would like to do, I store this again as this time as O3, and I would like to do some outlier detection with you. RapidMiner is open source. So the course, it's open core. The RapidMiner Studio is open core, which means we have also a huge amount of open source contribution. One of them is actually a package with most up-to-date anomaly detection algorithms. We would like to do one of them on the data we just pre-processed. You cannot just drag and drop in data from your repositories, but also full processes. Those are then executed, and the result is given you here on the right. I would like to note that you can also put data in, which is then received here on the left, inside that process, and you can also control the process using variables called macros. And of course, we have a full functionality of loops and branches and exceptions, so you can handle them as functions. In this case, we will only use the output and run it. That's what we already know. Let's do an outlier detection algorithm on it. There's a huge amount, like 17 different in that package and additional in the RapidMiner core. I like this one a lot. It's called histogram-based outlier score. It is something like the nice base of outlier detection algorithms, and it's very cool because what you get out is an example set where you have a new score, and you can actually sort by the score. So there's one guy with a score of 10.7, and you also see why he is that strange because of all this color-coded red values in here. So this is very cool. There's way more algorithms inside, and now we can say like, okay, everything above a 9 or something is an outlier. So just to highlight a few, if I go down here, I got my anomaly detection folder here. There are 15 different algorithms in. Some of them you might know, like LOF or clustering-based local outlier factor, or there's even one class SVM for outlier detection. So everything you want to have is inside. Let's move over to something to supervised learning. We have a label, and we can use this label to learn a model on it. Let's do that. Let's use, again, our preprocessed data, and then we would like to learn a decision tree on it. So we only search for decision tree, plug it in, and out here comes not just the table, but also the model itself. Let's run this one. What do we get? We get a tree. It's a decision tree. That's how easy it is to build a model. And you only now can drag and drop in SVMs, neural nets, a naive Bayes, random forests, and all the good stuff. We support more than 250 learning algorithms inside RapidMiner and build the model. And it's really that easy to prototype and to try out models. Okay, just learning is okay, but I like to validate that. I would like to validate that in a cross-validation. It's already recommended here. It's called X validation. Let's drag and drop that one in. This is the first operator we now see, which is a so-called nested operator. You see the small blue icon on the right. A nested operator is an operator where you can go inside. This is true for validation, which is kind of a loop, but also for loops or branches where several things can happen. Let's connect this one and actually delete the decision tree on the right. And by double-clicking on validation, we go inside. You see that the recommendation now changed. We get now on the left the training part of the cross-validation where we want to learn the decision tree. And on the right, we can do the testing, which is we would like to apply the model on the testing data set. And we would like to calculate a performance for classification. And if I click on the performance operator, you see that you have a huge variety of different performance measures. And you can always define your own one because you can extract a performance value from data. So you could also use an aggregate to find like the sum of customer lifetime or something. If I now go one up again, one level here with a small arrow, out of the validation comes the model and a performance vector. Now I can run this one here and get a confusion matrix. Apparently I got 95% accuracy, but well, okay, it is an unbalanced problem. We could, of course, now do different things, like we could sample down here or generate weights. There's actually a generate weights operator which generates a weight, which is then balancing the classes. There's also the option to add breakpoints with either F7 or right-click breakpoint after or before to see intermediate results. So if I run this now, it stops at the generation of weights, and you see that now there's a weight. It's actually the one is after it, so it's 0.0001, and for the true it's 0.002, and then the weight is automatically used. Let's run this to the end, and then we can get again some results. Now let's move to, I need to store that one here, as 04, learning. Of course, we can store models and also the results. So if I add a store operator, you already knew this operator from storing an example set. I can plug that one here, here, and here, and say store it as my model, and store this one here as my performance. And if I run this now, then I store that one in the repository right next to it. I can also use relative paths. And now I've got my model and my performance in here. Guess what? Of course, you can connect to SQL databases, all kinds of flat file formats, Hadoop HDFS, various connectors to Dropbox, Amazon, Marketo, Salesforce, so much connected to different cloud services. Everything is included. You would now like to run a modeling process every Monday morning because, you know, on weekend, the IT is giving new data into the SQL database you query. How to do that? If you only want to run it on server once, you just need to click not on this play button, but on this. Now it's executed on my RapidMiner server. But that's only once, right? Let's schedule it. How fast does this work? We can simply click on Process and say Schedule on RapidMiner server, or alternative F7. Then I say I would like to have a cron schedule and define the dates. I could, if I'm familiar with cron, I can type in the expression. I'd like to do that at 7 o'clock every Monday. If I now press on run, then it's run on schedule here, then it will be executed next Monday. That's how easy it works to actually schedule processes using RapidMiner and RapidMiner server. So how to score data then? How can we score using that model here? Well, guess what? I already prepared some new customers. Let's get them in, connect them here to the right, and have a look on it. Those new customers are very similar to before. We have, again, like gender, state, cardholder, etc., but we do not have a label. We would like to score them. To do that, of course, we need to do the same pre-processing. So let's go to pre-process, and we can simply, with control-click, copy them, and then we can paste them in here. Of course, now I got no fraud risk anymore, so I only want to set the row for customer ID. So ID, that's the only thing I need to change. And now I can use an apply model operator here to apply the model to this data set. And that's it. I can simply press on run, and now I get a score data set with confidences and predictions. This is how easy you can score your data. It's very, very simple to do. And of course, you can now schedule this one and here not query an Excel file, but any data source you want to do. I'd like to move over to Hadoop. There's a Hadoop perspective called Hive Management. If I go over here, you see all the clusters I'm connected to. This one is 5 meters next to me. And the cool stuff is that I can actually open such a data set, and if I double-click on it, then I get a sample data with 1,000 data points and can do all the charts and all the statistics we have done before. So you can easily get access to the data and have a look at it on a small sample, but well, you don't want to copy a terabyte to your laptop anyway. You can change the number of 1,000, of course. This said, you can easily explore data. Let's see how we can do exactly the same stuff we did before on Hadoop. I already prepared the process because we are lacking a bit of time. Let's apply the model on Hadoop. So what I can do is I can retrieve the model I just stored and put that one into a Hadoop nest. Everything which is in that nested operator where we can go in again is happening on the Hadoop distributed on the full cluster. We don't do something on one core. Everything you do in there is done on the full cluster. The cool thing is you can put things in, also data, and get things out, also data, models, whatever you want. If I go in there, you see that I only use special operators from the Hadoop extension. There are actually like 70 operators you can use in here, and guess what? Most of them you already know. Retrieve gets data from the repository. In this case, it gets from Hive. Filters examples, state smaller than 51. Generate attributes, generates delta transaction, apply model, and store. This time it stores into HDFS. So you already know how it works. You just need to use the yellow operators in case sometimes it's a Spark operator. Now, we cannot just apply an in-memory learned model on Hadoop. We also can learn models in Hadoop. How do we do that? So I already prepared that one. And this time, nothing is going in on the Hadoop nest, but I retrieve the training data set, the fraud training data set, and I filter again for 51, generate some attributes. Then I do a type conversion to get fraud risk into binomial because it's stored as polynomial or string. That's the row, and then I build a decision tree. In this case, we use the mlib from Spark. So this is a Spark operator. We support various learning methods from Spark's mlib, and we also support the variety of scripting languages. You can use PySpark, SparkR, and Scala with Hadoop. Actually, we support also a lot of scripting in memory, which is then Python, R, Octave, JavaScript. And again, since we are open source, you can build native extensions to RapidMiner in Java. The Hadoop extension we have as a separate product is technically an extension. So all the stuff you see here is developed with the same framework, which you can use. Again, RapidMiner Studio is available on GitHub. As a last step during for my presentation, I would like to show you how to integrate Python into your processes. So let's start a new process and again use our pre-processed data. Now I would like to learn a Python model, an sklearn model, but it would also work for R if you want to use R on this data set. I already prepared something for you. There's a cool productivity feature which is very, very useful for data scientists. Keep in mind, we are talking about a data science workbench. So this is a workbench where you should get most productive with. Part of getting most productive is having template functions or predefined scriptish things. We have something which is called building blocks. You can combine different operators and store them as a repetitive building block. If I hit Control B, you can see all my building blocks. Some of them are already prepared by us, like a nominal cross-validation. Others, all the one with the icon here, are done by myself. And I prepared something which is a BDT and sklearn, and I can add it here and put that on the line. And it works similar to the apply model, the decision tree operator you already know. It returns a model. This model is a file object. It's not handleable for RapidMiner operators, but for other Python operators. So let's see what script have I built. So this script is a pretty easy script. It says random forest, but it's in fact a gradient boosted classifier from sklearn. So what do I get here? I simply define a Python function where I get the data, and I also get the metadata to ignore all the special attributes and figure out what's the label. And then I simply define a gradient boosted classifier and say fit on the data without the label as X and data on the label as Y, and I can return the classifier and the data. The data would be available here. I can pass that one through and also have a look on it. Everything pretty easy. Then I get the data back. And now, of course, I can also apply this model. So let's, of course, I don't need to have the apply model from Python, but I can use the apply model operator I configured here. Let's use a kind of split validation. Let's split the data a bit to not apply a model on data we already used. In the upper port, I would like to have 99% of the data. In the lower port, only 1%. Then I connect the model here and the data here, similar to the apply model operator you already know from RapidMiner. So again, this one here is a script. It is a function which gets a classifier and data, and it is doing similar things than before. It's actually finding metadata, throwing out special attributes, and then it's using predict and predict proba to predict confidences and the label, joining back on the data, and then returning the classifier and the scored data set. So this is a very easy function you can store as a building block in your Workbench, and that's it. If you now connect this one here, then you have integrated sklearn BDT into RapidMiner. Very cool for this is, of course, if you would like to share this one, so I can share a Python, sklearn Python operator to my colleague who's a heavy R user, and he doesn't not need to use Python anymore because they are looking pretty natively. So you can share those processes with your colleagues and then leverage from a huge variety of things. Of course, this also works for HiveScript or PickScript in Hadoop. This works for SparkScript, so SparkR and PySpark on Hadoop. You can also share this one. You can use this execute process operator to use functions. You can also integrate. You can also integrate various other web services. So you can call web services from RapidMiner, of course, or different cloud services. That's it from the demo side of view. Let's go back to the slides. I would like to introduce you to our users conference, RapidMiner Wisdom. It's in January in New York. I'd like to invite you to join us there, join the community. And there's a 40-day free trial of RapidMiner Professional, and of course, also the open source community version available on rapidminer.com. And thank you for to listen to me, and I'm happy to answer your questions.
Well, Martin, thank you very much for that excellent presentation. We'll get started with today's Q&A session. And I want to thank the audience for their participation. We've had a great many questions that have come in during the presentation, and we'll do our best to get through them all in the time remaining. So during this Q&A session, I'll leave up this screen with contact information for Martin if you'd like to contact him following today's webinar. So let's get started. Martin, our first question. Do users have to create the process for reading Excel spreadsheets?
Not necessary. So either you can drag and drop them in or do the read Excel operator, but there's also an import data option in RapidMiner Studio to directly load them into your repository.
Well, thank you. And so like R and Excel in RapidMiner, can we also use like Bayes' theorem or decision trees for classification? What other modeling techniques are available?
So we have like the full variety of stuff you can imagine. Just to name a few, there are different versions of SVM, random forest, the different decision trees, neural nets, Bayes' theorem stuff, of course, linear regression, polynomial regression, KNN. There are more than 250 machine learning algorithms, not just machine learning in terms of supervised learning, but also clustering, association mining, and outlier detection.
Well, thank you. So our audience would like to know, is there any way to design a process in RapidMiner and run it in the command line?
Yes, you can. So all your processes are stored as XML. And you can also copy and paste the XML into an email and send around to your colleagues if you want to, or use Git to store the XMLs if you like that more. But you can actually use the RapidMiner execution engine to execute execute that XML.
Well, thank you for that answer. Now, obviously, some of our audience are very interested in visualization, particularly using the popular Tableau or Qlik applications. So, does RapidMiner export native files for Tableau and Qlik?
Yes. So we also have a web app function in our server, which is giving you a lot of BI functionality, which is tightly integrated into RapidMiner. But also we support Tableau TDE, and we support to write into QlikView and easily integrate into both systems. Further, we can offer web services, so you can turn any process into a web service, which is then returning one table, and then you can integrate RapidMiner into any other IT system with this web service, which can also get data and get options. And of course, this can be used to also integrate into other BI systems, but Tableau and QlikView are definitely supported.
Great. So just to clarify, can it be used in conjunction with Tableau dashboards?
Yes.
Okay. Thank you. So you talked about Hadoop, and obviously our audience is interested in unstructured data. Is it possible to break up basic text from a file into structured information?
Yes. So as I said, we have a big extension, a marketplace with extensions. Some of them are maintained by RapidMiner. And there's the text mining extension, which is able to tokenize, so to generate a bag of words out of your text, and then you can further process that one and even combine the unstructured text with the structured data into one big model or several small ones. All you want to do is possible there.
Okay, so we'll drill down a little bit. What specific operators are used to run stats on text fields?
So this text mining extension has additional, I don't know, 50 operators or something, which gives you like all the good stuff you want to do in text mining, like stemming, pruning, using dictionaries, cutting documents into parts. You can even read documents from IMAP account. So very different things to handle your text files.
Well, thank you for that excellent answer. So, you know, in the production mode, how do you automate model building with hundreds of models and choose the best one?
So I'm not exactly sure so it could either now mean that you want to optimize settings and this way get different models. So in that case, it is there are several optimization functions in either by nested for loops, a grid, or with evolutionary selection. And then you can simply say, I would like to vary this parameter and this parameter and this parameter, press on run, and you get the best model back. There's also the option to use several models inside and then optimize also on which model to take.
Excellent. Okay. Back to visualization for a minute. Can RapidMiner be used to produce actionable dashboards? Does that require RapidMiner Studio to be read, or can it be exported to other formats?
So we have the option to run web apps. So if you have RapidMiner server, you can design a dashboard. We call it web app because it's a bit more interactive. You can pull data in and get data out and even run arbitrary RapidMiner processes. And these web apps are accessible from the web with simply a web browser. And you don't need to have RapidMiner Studio installed, or simply use your you can simply use your web browser to get to those web apps.
Oh, thank you. Thank you for that answer. So in terms of actually using RapidMiner, the web services, are those only available as cloud services, or do you also install on-premise?
They are available on RapidMiner server, and RapidMiner server can run wherever you want to. It does not need to have an internet connection. So it can run in your local network. As I said before, during that cast here, I used a server which ran on my Windows system. You can use any Linux somewhere. The only things you need is Java and SQL database, and Postgres is fine there.
Well, thank you. There must be some RapidMiner users in the audience. They're asking, what specific version of RapidMiner are you running, and what add-ins are you using?
Yeah, that's a great question. So I'm running the latest version 6.5 actually in the developers edition, which is similar to the deployment edition. And what extension have I installed? That's a good question because there's this marketplace in RapidMiner where you can go to, and I tend to try everything out which is in there. So there are like, I don't know, so many extensions already in, and I really like to feel this open source and get the things in, try that one out. So maybe I don't want to say like all of them because it's currently like 15 or something, but let's focus on the ones I use most frequently. And those are definitely Hadoop. So our Hadoop extension, which which I use very totally often. Of course, the extensions for unstructured data, so time series extension and text mining extension. What I really love is also the anomaly extension, which is an open source thing. The Vecca extension to get all the Vecca stuff in. And there's a very, very cool new extension for text analytics from Alien, which gives you even more power in text mining. I like that one a lot.
Yeah, that's really the fun of open source, isn't it? You get to try out everybody else's good solutions.
Yes, and you can get such cool things in and that many things in. That's amazing. Right. And this big open source community we have, and we actively support them and embrace them, is really great. I want to send a shout out to you guys who help us to build this Workbench. Thank you.
That's nice. So here's a technical question. Obviously, a data scientist in the audience. Can you do normalization inside cross-validation?
Yes. So it's not like, so as I said in the beginning of my talk, we are coming from data science. You can put every pre-processing operator into the cross-validation, and there's an operator which is called group models, which allows you to group the normalization model together with your actual prediction model. And then they are executed together if you apply them. That way you can do an accurate and correct validation and get the correct performance value.
Okay, terrific. So now back to a more general question. What data sources can you access with RapidMiner?
Those are that many. So all flat file formats you like, there's Excel, Access, CSV, there's even a BibTeX operator, a sparse file format operator, a lot of SQL databases, so everything which has a JDBC driver works. Out of the box is Postgres, Oracle, Microsoft SQL Server, MySQL, so all the stuff you use. Then of course HDFS from Hadoop, not only through the Hadoop extension, but also with Studio Professional. Then there are a lot of cloud services like Dropbox, S3, Salesforce, Marketo, and all the stuff. And also NoSQL databases like MongoDB, Cassandra. Yeah, so I missed a few ones for sure.
Oh boy, it hardly seems like there are any that you can't access. Now, another question from the audience. Would you speak specifically about RapidMiner's capabilities with unstructured data?
Yes, so I already mentioned that I installed and talked about text mining. This is, of course, the strength of RapidMiner. Time series extension I mentioned. There's also an extension which is able to do image analysis. And most notably, we also have an extension to run audio analysis. So all the good stuff is available in RapidMiner.
Oh, that's fun. Well, Martin, thank you for those great answers to some very good questions. For those of you that asked questions that weren't answered today, we'll be sending all the unanswered questions to Martin and the RapidMiner team so they can follow up with you today after today's webinar. I have just a few quick announcements. First of all, today's taping will be available for on-demand viewing later today, and you can find it on the home page of Data Science Central in the Webinar tab, and that's located at the top of the page. So please mark your calendars for December 15th. That's our next Data Science Central webinar, How Flextronics Uses Data Visualization and Analytics to Improve Customer Satisfaction. And that'll be sponsored by Alteryx. Well, this brings today's webinar to a close. I'd like to thank our audience for their attendance and thoughtful questions. And a special thanks again to RapidMiner for their sponsorship and our speaker today, Martin Schmitz, for his insight into today's topic. My name is Bill Vorhies. I'm very pleased to have been your host for today's event, and I look forward to seeing you all again on December 15th. Have a great day.